My name is Sean McAdams. This talk is going to be called Devops Experiment. It's kind of an experiment on the capabilities of a handful of CI tools. Kind of the one thing I like about DevOps is you can kind of replace any of these tools with another set that maybe better fits your stack or something like that. Circleci you can replace with Travis or Jenkins or however many other CI tools. Terraform, obviously you switch with like Ansible or something like that. Azure, I don't even have to go into it. But the point is that you can replace each of these tools with what fits for your environment. So again, this is kind of just an experiment on one version of this CI process. I really think everyone should kind of try their own version of this, try with their own tools that they want to use. I personally learn by doing, so I rather do it than just watch someone do it. But it's good to just see what is out there and see what you might want to do for a project of your own. So about me, I have over 8 years of professional experience. I'm currently a staff software engineer at Black Diamond, a company in town. We do financial and portfolio management software. We kind of focus on .NET and a little bit of Node.js stuff. I've done work on-prem and in the cloud, though mostly Black Diamond is a more on-prem situation. And because someone told me I had to put it up there, I'm Docker certified associate. So here's kind of the list of tools I'm gonna kind of go through for this talk. Docker and Docker Compose and Docker Swarm. I'll just say Docker over and over again. There's going to be a lot of Docker. Anyone not know what Docker is here? Okay, good. Give a good start. I'm going to use Artillery for some load test, kind of load testing. It's a really cool tool that's basically a Node NPM package you can pull. I'll show it later. Circleci is the CI tool for builds. Terraform is what I'm going to be using for provisioning the Azure cluster. And then for monitoring, we're going to check out Grafana and Prometheus and kind of see how you would want to monitor applications in an Azure cluster. So I'm kind of just going to jump right into it. Majority of this presentation is going to be either code or demos. So pretty much, let's just get started. So the app that we're going to be pushing out to Azure is, of course, my Windows VM decided to pause. Let's just go ahead and here, it's a .NET Core 2.1 app. Yes, I don't have to do it in Visual Studio, but I wanted to. Wow, does not like me today. Eventually, this will start up. Live demos, man. Anyways, so it's a .NET Core application. It has an API. It has a offline worker. It uses a message bus. Has a database, which is Mongo. All it really is there's an API endpoint that creates a message on a queue. That message gets sent over to the worker via bus. Pretty straightforward, simplistic application, but mostly just to show all of the inner workings of the cluster or Docker Compose and running in Swarm. Particular details, if someone's interested, my VS Code, of course, has plenty of red lines, and you guys can barely see that too. All the red lines. So, but it just has a create endpoint, and it has a get endpoint. So create endpoint just makes a GUID, drops the GUID onto a bus, the worker picks it up, writes it out to Mongo. The get basically does awful stuff to wait for it to exist, and then returns the GUID. Not much to it. So the main details here will be in these Docker Compose. So just kind of get started. I'm using multi-stage builds in Docker to basically, we're going to take the app, it's going to build in a Docker container, it's going to create containers, push it up to Docker Hub via Circleci, and then we're going to deploy those containers out to an Azure cluster, which I will spin up via Terraform script, and then we're going to run load tests against the Azure cluster and kind of see the performance via Grafana live. So just to show you, this is actually working on in general. So anyone not familiar with Docker Compose? Quick overview of Docker Compose is you're just defining out all of your services in a Compose file. Rabbit, Mongo, and you define the ways those services connect to each other and how they intend to talk. In particular, these are like environment variables. One of the things that I want to mention is when you're building applications that fit in a cluster environment, in a scheduler like Swarm, you want to try to build them as stateless as possible. Has anyone ever heard of the 12-factor app? 12-factor app is a great kind of, it's a really short read and it's really good. It explains how to build applications for deployment on a distributed system. It talks about statelessness, how you provide config information. Like you want to try to build your apps as close to 12-factor as you can get. However, of course, if any of you are familiar with 12-factor, you know you usually can't get all the way there, but any amount of them are good. But the point is that the API is stateless, the workers are stateless, they are pure input-output results. So we can scale them up or down without any worry of having to pin nodes for sessions and do all that kind of stuff. And this is why the environment variables here are how this is one part of the 12-factor app, is to be able to provide your connection strings via environment variables. So it's just one example of that. Let's go ahead. I already got that up and running. You can see it's running all the individual, everyone can see this? Okay. Running all the individual workers, and can do a very basic create. For not found. Yes. Just create the good, and that's, so this is very, very basic. I just wanted to show the overall what this is intended to do, because I'm going to be using this for the load testing of the application, or load testing in Azure. And we're going to do that via Artillery. Artillery is again, like I said, a really nice tool built NPM package. You can define out phases of basically your load tests that you want to do, and you can define out how long you want it. So these individual phases, you set a duration, how long you want it to run, how many requests per second you want to come into the application, and you can define out each phase. So you can kind of mimic a production-like workflow in that, hey, during some time of the day you get higher traffic. It's just a way to create a load testing, and you define out your flows and scenarios here and how you, basically your test scenarios. So as an example, throw that together. Let me go to the right shell. So if I was running this against my local box, which is I have to save it before I do that. But it's going to pretty much destroy my local computer because it's going to send way more requests than my local computer can handle. But it's a good baseline to see. It's just what you can see the output of what you get, individual requests per second sent, how fast they are, and so forth. I'm not going to let the whole thing run because it takes a while. All this code is on GitHub, so if I'm going too fast, just tell me and I can explain some more of individual pieces. There's a lot of little pieces involved, so I'm going to try to get through it relatively quick. And all right, so that's pretty much the piece of the app, discussion of the app, a couple small little.
Can you point artillery at anything besides an endpoint?
It has a couple other features. It's mostly used for web load testing, though. So a couple small things that want to specify. You want to use multi-stage builds in Docker. I should have shown you that real quick. If you guys aren't familiar with multi-stage builds, it keeps your Docker images slim. You start with a build environment, you do all your build stuff, and then you copy it into your runtime environment. So in this case, I'm building the .NET 2.1, pushing it, publishing it, and then copying the published information out into the container, and then starting it. And then you want pretty much, the nice thing about Docker obviously is you want your local environment to mimic your production environment. And to do that, you have to have local compose, which is what I had there. You have to have everything set up. It's definitely worth the effort to get all of that set up locally because you want to be able to test in identical environments. And then let's just go into the kind of bulk of the, I can do Circleci. Let's show you the Circleci piece. So let's just make a quick change to something random. I'm just going to add a couple pieces here just so you can see the Circleci part of this. So I'm going to go ahead and stage this. And bars in the way, of course. So Circleci is a nice little CI tool. If anyone's used it, it has a really simple setup process. And I have it linked to my GitHub project, the specific GitHub project. They have tutorials on how to set all this up. I don't want to go into the specifics of it because it's relatively trivial to set up. The key piece is that it's connected straight to your GitHub profile. You get this normal, you commit, it auto runs your builds. This is an example of a Circleci job pipeline. The main point of this is that you pretty much don't need anything other than Docker to do all your work. If you set up the multi-stage builds, you set up your compose files, all you need to do is start with Circleci uses Docker as its build environment, but you kind of need to have Docker in your Docker build environments. So they have the process where you can pull in, you set up a remote Docker connection where it actually connects out to a different Docker socket, and then you install the Docker client Again, most of this is pretty right out of the Circleci tutorials on Docker, but this kind of is the important stuff. This is doing the actual build. One of the big things you need to think about when you're doing Docker releases with Docker images is to make sure to tag your individual images specifically with build numbers and then release them with those build numbers. A lot of people use the latest tags on Docker, and that tends to lead towards really unwanted results. Containers tend to get cached on individual boxes, so latest tag on one box might not mean the latest tag on another box. So you want to do specific tags. It's just kind of a nice to do. Okay, we've got the build, and I will go to Docker Hub just show you guys. Publishing, see over here. Up in Docker, it publishes each tag directly to Docker Hub a minute ago. So now I want to go ahead and, now that I have this application, I want to get my cluster started. And this is kind of the meat of the presentation here, is around Terraform. So Terraform, if anyone's familiar with it, is a provisioning tool. You can provision pretty much any type of infrastructure they have connections with. Terraform uses kind of a state management process to where when you run a Terraform script, it initializes, or you run Terraform init, it kind of creates this state bucket. And when you do a Terraform apply, you'll see here soon, it saves what it did to that state. In this particular case, it calls these are backends. It basically is a storage location for your state. It pushes that state and out to Azure and saves it as it's doing it. So as you change the Terraform script, say you want more ports in your load balancer, you want more VMs, in this case, these are a handful of variables. So in this case, I'm saying I want 3 VMs right now. If I come back, which I will, and bump it up to 5 VMs, it's going to know that we had 3 VMs, and it's going to spin you up 2 more, and it will connect all of the, in this case, I have a load balancer connected to all of them. There's a availability set that includes all these VMs. There's also network pieces involved, so it knows the current state, and it knows the state you want to get to, and it applies the difference to the cluster. I'm going to go ahead and get that started because it takes a little time. So Terraform uses naming conventions for its files. Main.tf is what it runs when you do the normal Terraform apply. It has variable files that get expanded in your individual files. So you can set these variables so that, say you wanted to spin up 6 of these clusters or something like that. You can just run the same script with different variables and come out with new clusters. In this case, I'm only going to make one particular cluster, but and I'll go through a couple of the details here. But again, Terraform is going to create a resource group, create some security rules around allowed inbound connections, availability sets up a public IP so you can connect to it externally, sets up a virtual network across all of the VMs so that they can communicate with each other, creates a load balancer, creates, in this case, which you probably should never do, it creates NAT rules that expose the SSH ports out through the load balancer, because I need to get into those boxes right now. Then sets up load balancer rules, which will look for the particular ports that I want and basically tell me when any of these ports are not available and bring down nodes. So say you were planning to, one of your applications goes down across the whole cluster, or even a handful of things you can manage. It's standard load balancer probe. You just be able to identify when certain ports are removed. And then network interface sets up. Going through each individual one, the interesting thing about Terraform is it's a bit of a learning curve to get used to, and the syntax is kind of specific. It's its own syntax. What I tend to do is I tend to go into Azure, for instance, let's go into Azure, set up my cluster kind of by hand the first time. See, in particular, Azure can be pretty hard to tell exactly all the pieces you need. You need like network security rules, you need all of these things in order to get everything to work. But if you kind of do a cluster once and then see all of the dependent pieces you need, you can reverse that into a Terraform script relatively easily. Terraform's documentation is really nice. You can go in and say, in this case, this is a storage account. I wanted to create a network share across all of the VMs. It's really easy to find information on the syntax for creating a storage group, and they have examples all over the place, and they have all of the arguments that you would see. The nice thing about this is you can go to Azure and you can be like, when you're creating it, you'll see all these properties in the Azure portal as well. And again, you can just kind of one-to-one map them back.
Yeah, so is Terraform basically like a, I guess, a declarative alternative to like the PowerShell scripts in Windows or something like that?
Yeah, normal like Azure automation, you do it via PowerShell scripts and all that kind of stuff. This declarative syntax. The nice thing about Terraform is that you can point it. It has AWS syntax. You can point it at on-prem VMware tools. It has a wide range of providers that it supports. So it's kind of nice to have single tool, declarative language. There's a lot of support on it. They have tons of examples on how to do it. But yes, again, you could replace Terraform with your own hand-rolled PowerShell scripts with Ansible or anything like that. I enjoy Terraform because the syntax is pretty easy to understand and how it resolves variables as well. It's kind of nice. So in particular, if I go down to the VM here, you can see I end up pulling in the VM count variable, and it has an interesting syntax for pulling the IDs from the pre-created other items. So in this case, the network interface was created first. I want to pull the Azure ID from that network interface, which you wouldn't be able to pull unless you already created it. It captures all that, and you can use it in the subsequent resource definitions. In this case, there's a lot to these Terraform scripts, and if anyone's interested in the specifics of these as well, I can go into it kind of after. The last piece down here, once all the VMs are created, all of the networks are set up, the load balancer is set up, we have to actually provision the VMs to run Docker, right? So I want a cluster and a swarm on these VMs, but I don't want to have to hand set it up every time either. So very much like Ansible or PowerShell scripts, you can run remote provisioners that execute a handful of commands. Some of this stuff probably would be a little bit cleaner in something like Ansible, but just alternative tools. In this case, I do some updates to some apps, create some directories. I mount the Azure file share, and I start configuring the swarm managers. How many people are familiar with Docker Swarm? All right, so how many people are familiar with Kubernetes. So Docker Swarm and Kubernetes are just orchestration tools. They are used to automatically deploy all your applications that are defined, in this case, the same way that I define them locally with Docker Compose. I can define a Swarm Compose file here and define out all of my deployment information. So say I wanted this to have 5 replicas across all the VMs that I have spun up. I can just come in here and switch it to 5. And there's also a couple other ways to scale with Swarm. Swarm versus Kubernetes, classic argument. Swarm, I tend to find, is a lot simpler and a lot easier to start up. Kubernetes is a lot more robust and can be used for pretty much anything. In this case, if you don't need Kubernetes, I like to do Swarm. So that's kind of what I'm going with here. All right. You can also define the update config. Update is when you push a change to a Swarm node, it will rolling deploy your application. And you can say, I want to deploy 1 every 10 seconds, and you can roll out your application slowly instead of, so in this case, if I did 3, next time I updated it, it would do 1 every 10 seconds. That's all it is. Pretty straightforward. It's part of what I like about it is that it's all relatively easy to understand. If you see a script, you can tell kind of what it's supposed to do, and it is not as convoluted. All right, let's go back to the Terraform thing. So in this case, I initialize the Swarm manager. I actually write out the join tokens for the Swarm out to a file share, which is mounted to all of my VMs. And then on the rest of the VMs, I join them to the cluster as part of this entire script. So when I run this, it's going to go through, do all of the provisioning for me. And just to prove that I didn't start with anything, if I go to resource groups, the only thing I have right now is the storage resource that holds the Terraform state. So you want some sort of remote location to store the Terraform state, because say if you move from computer to computer, you won't have that state with you. Terraform, by default, saves all of the state to a local file or local folder, technically, which obviously doesn't help you anywhere if you have multiple people on your team or things like that. So you always want to store your Terraform state in a remote spot, and that's all set up via this back-end process here. Set up your storage account, containers, and whatnot. I hid the client ID in secret, obviously, because those are secret. All right, so I'm just going to go ahead and hit apply. It's going to look at the current state of the cluster. Well, first it's going to ask me for any variables that I don't have defined. In this case is the administrator password, and I don't care if you guys see this because I'm going to tear down this cluster right after this. And you see it looks at the current state of the cluster, goes through and shows you all of the resources it's going to create, all the details related to it. And at the end, it gives you a little summary and says, okay, I'm going to add 38 items. So, and just start running through it. And so now it's going to start spinning up all of the pieces of this cluster that we need. And you will start seeing it right now, the resource group created here. And you will start seeing items show up. It will create the VMs and everything. This takes a little while, so I am going, while this is running, I am going to show you the local Docker Compose stuff. So I already ran the local Docker Compose, but say I wanted to test my actual deployment artifact, the container that I put out on Docker Hub. Obviously, it's just the same as if you're pulling anyone else's container, but my local compose file has my local builds, basically. So I would have to build this and run it. But if I wanted to, not much different, you're just pointing at the thing. Here's the one thing that I found with Docker Compose that's super useful. So you have bash style environment variable expansion in Docker Compose. So you can here say, I want to expand this tag environment variable, and if it doesn't exist, use latest. So in this case, if I didn't care what tag I wanted, I could just let it do latest, or in the command, I can just go ahead and all of this manual stuff can be automated, but this is just a basic example. So I want the latest one, which is the tag 1.5, and then I can just do cool, because that's a percent and not an and sign. Must bash. And I did that wrong again. So pointing at the new the released Docker Compose file, which has the separate definitions. Same, this is almost identical to this compose, and you technically don't even need to make another compose, just kind of preference. You can chain the Docker composes and you can inherit from another Docker compose. So you wouldn't even have to fully define this. You can just have these image tags and everything else lines up. And it'll pull the latest and do it. So I'm going to do almost this exact same thing on the Azure cluster with this swarm compose. The only difference will be that I will be using Docker Swarm instead of Docker Compose. All right, and just because, and you can see it's running pretty normal. Let's see if the Terraform is done. It's pretty close. So now we can go over here. You can see we got all of our resources set up, VMs, security groups, the backing disks for the VMs, the network cards, and the load balancer with all of the pools configured, health probes defined, and NAT rules in place for SSHing. Cool. Also to mention, this Terraform file at the very, very end spins up a couple Docker services. In particular, it spins up Portainer and Visualizer, and also spins up my Grafana stack, which we'll be using later. Portainer is a really nice tool free tool for managing Docker Swarm clusters, and I'm pretty sure it works with Kubernetes scheduler as well. Visualizer is just super useful when you're using Swarm. I'll show you in a second. The Grafana Compose is set up with Prometheus, targeted to, you notice I am mounting into, so this mount swarm data, this was the share that I created earlier that's mounted into the VM, because I want to be able to potentially spin this up on it should be able to spin up on any of the managers. In this case, I have a role constraint of a manager. Should be able to spin up in any manager and I don't lose data. So I want to mount the data directories into some network share. It's anytime any service that you're running on Docker Compose needs a data directory, you really want to mount it to some sort of network share. Otherwise, you're going to lose data when it gets migrated from VM to VM. So everything's set up, you can see, and it also, I even set up the DNS entry for it. So this is 9000 for Portainer. And this is entry point to Portainer. And you can come in here, shows you, in this case, this is the primary cluster that's set up on. Right now, there's only one stack deployed, which is the monitor stack, which is the Prometheus stack that I created with Grafana. and you can see each individual service that's already spun up. So this is all done. Every single one of these things is done via the Terraform script. So it's kind of this nice central place. You can put everything in there and manage everything through that. And then you can even scale over here, which is I'll show you in a second. And visualizer, 8080. If you guys seen this, this is visualizing it does what it says. It visualizes the entire swarm, what containers, where they are, and what manager is running. So let's just go ahead and come over here. Now I want to deploy my application out to this cluster, and I am going to do a couple manual steps here, which are obviously really easy to automate. They're all just command line things. I'm going to copy over my, I'm going to SFTP the Docker Compose Swarm item here over into my cluster. And I have these extra flags so I don't, in particular, if you keep spinning up and down Azure clusters, SSH gets pretty particular because you're basically the signature from your original SSH call now will be wrong the next time your stack comes up because all of the VM information is wrong, so the entire checksum fails. And I use the password that I set up earlier. We'll do this pretty quick. So I copy over the swarm. Let me go ahead and SSH into this. And now I'm into the cluster, and you can see the container's running. This is all the same information you can see in Portainer. You can do everything via the command line. These are the services are running, and then the stacks that are running. I can't spell Docker. Stacks that are running. All right. So now, if you look right here, the compose file should be right there. Now I just want to do the same exact thing, except I want to tag the latest tag. And this is all you need to do to create your service. Now it'll spin it up. And you can see it is now spinning up my NetCore example stack and right now it's going across all the VMs and pulling, in particular, it's probably pulling the image layers right now, and you'll eventually start seeing them show up in your monitor stack. Portainer here, and these guys are already starting to come up. And you can see them come up. All right, so from that, let's go into, any questions so far?
So is it best practice to name your application prefixes as all caps and the monitoring as lower?
It's just kind of my thing. You'd rather not. I like the caps because they're easy to visually pick out. The system containers I tend to leave in lowercase process. So now, I want to go ahead and look at the resource utilization via Prometheus. Now we have everything running, I have my apps running, I have all the extra stuff running. Now I want to see how my cluster is doing. So this is where I dive into Grafana. So Grafana is a data visualization tool. Prometheus is a time series database. Grafana feeds from Prometheus, and I will show you Prometheus as well. 9090. So this right here, what ends up happening with the monitor stack is I have two different exporters, and exporters are basically containers that are on each node that have endpoints open for Prometheus to pull and pull data from. So in particular, there's a container called node exporter, which exports the individual VM's specific metrics. In this case, the time it takes for the VM to boot, or in the better ones, obviously, are CPU utilization here. And I'm showing you this merely as an example. So it has a bunch of CPU information. When you go over to Grafana, and we'll add data sources, this will be Prometheus. And then from in the stack, the Prometheus stack, as I showed you before, the service definition is, these will be the actual names of the containers. So you can actually use Prometheus in your URL here. And this is all internal to the Docker Swarm, or the Docker Swarm network that's set up. So none of this is exposed, and it's all nice and hidden away. So I added Prometheus as a data source, and now I want to go create a dashboard for it. I'm going to get a pre-created dashboard because it makes it a lot easier. There are a lot of dashboards out there that people have. You can find one either on the Grafana site itself. There's a bunch of that just have raw IDs. The main thing is it tends to depend on what exporters you're using, and that some dashboards are expecting metrics from different exporters. So in particular case, the node exporter might not have the same CPU named metrics as the next container thing. So I have this as a basic dashboard. Go ahead and load this, set my Prometheus data set, and it all comes up. So these are all pulling from Prometheus to determine the usage on the clusters. If you go into here, you can see each of these is predefined. This is merely a Prometheus query. I can take this exact same thing, go over to Prometheus, drop this thing right here, and I will see the same exact graph that I see in Grafana. It's just a nice way of pre-aggregating that data. And you can see all of the other ones as well. So this will have every container. Obviously, this is really hard to view. So you'll have to be, if you want specific information, you can drill into them. But now that we have monitoring in place, I want to see what it looks like if we put load on the system at this point.
Sean, quick question. That Prometheus query, that's something you set up via your dashboard? That's something you specified in that dashboard?
Yep. Yeah. So in here, each of these are basically their own query and their own report, effectively, and you define the Prometheus query in this definition. So each of these has their own definition, and there are hundreds of metrics that could be pulled. So one of the difficult things for me was to figure out what I wanted to see, and normally everyone wants to see something different. So it's really nice that Prometheus is really customizable, and Grafana are really customizable, but it's really hard to get it to where you want it to be. So I suggest starting with something that's already pretty close and going from there. So in this case, I have memory usage here, network input, CPU usage, and fun little dial graphs over here, just so it looks really nice. Not whether or not you want that is completely up to you. So now I'm going to go back to my artillery script that I ran earlier and change from localhost. I'll change it back to my Azure instance, and then I can go over here and, nope, one more, and say run the same exact test against now my Azure cluster, and you will start seeing traffic come in a moment. CPU usage will increase. Now what we'll end up seeing here is that are the main bottleneck in this case would be the connections to Mongo, and you won't see it initially, but you'll eventually start seeing the Mongo container get really high utilization. It should show up here soon, unless that broke. It's not even hitting it. Live demos, fantastic. All right. Let me make sure the stack is up. And see, that is pretty interesting. The whole thing isn't up. You know how that works. It's great. All right. Looks like my stack didn't come up. That's fantastic. So live demos are, of course, the worst thing that you could possibly do. What should be happening right now is I should be able to hit this 80 port and access my container, and it clearly did not work. SSH. But you guys get the general idea. You can try to redeploy it just to make sure. Effectively, you would start seeing a Mongo container start to get too much traffic. And what you'd say, well, how do I debug this? My Mongo container is behind my load balancer. I can't get to it, blah, 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 blah. What am I going to do? You can go back over to this Terraform script, variables, and say, well, you know what? I actually need my Mongo port exposed. Is it 20? I think it's 27017. Let me just make sure, because see, I don't need that. Yep. So add that guy, come back over to Terraform, do a reapply, put in my variables again. It's going to go get the current state. It's going to be like, okay, what are we missing? Oh, I'm missing a port. Oh, I'm missing, in this case, it will try to reprovision it. It's missing the load balancer rules, the ports, and everything. So I'm going to go ahead and deploy the port change, and you'll end up seeing that port show up. And now I can just go ahead and say, or if you use Mongo Compass or whatever tool you want to use to test these things, now I can go and connect to the Mongo cluster, which chances are I have the same problem in that there's some a network issue, because, oh, the load balancer isn't done yet. All right, while that is spinning up, I will show you. Go ahead and stop this guy and try to redo it. Chances are it is something with ports, but anyways, you can re-expose the ports. You can go in there, check it out, do what you need to do, and then close the ports back off using the same script. Now, in this particular situation where, say you wanted to scale an app, you can always come in here and scale up these guys in Portainer, or you can do it in an automated fashion. Everything's going to hell because I'm doing it live. I did this right before this talk, by the way, and it worked perfectly. But that's the way it goes. So you come in here, you can scale them, or you can go and re-SSH over there and change your swarm file, add replicas in here if you want to do it that way. But also, say I wanted to come in here, and another nice thing, obviously I can just bump up the VM count, and then I can say, oh, okay, I want 8 core machines. It's like really bump this up, and you can just go ahead and apply it. And it goes and creates, it'll scale your VMs and change them when you need to. Saved.
Oh, I'm looking at SSH. Never mind.
Thank you, though. Good, good. This is really useful, particularly if you don't like paying Azure money, because you can spin up and down your VMs and you don't get charged for them while they're active, because those 8 core, these D8s, which are like 8 core boxes, cost me like $3 an hour or something ridiculous. No, it's not that much. I think it's $3 a day or something. But still, I prefer less cost. But it's the same thing if you say you wanted to do some sort of integration environment, or you had some sort of CI process where you decided, I want to spin up my entire stack in a cluster, do something with it, and then spin it down. You could automate all of this. Everything's via command line. You can automate every aspect of this. So you kind of piecemeal everything you want into the process that you're looking for, and these tools just provide you that flexibility. But all right, that's pretty much all I got. If you guys want to see anything else, you can do it. Or any questions?
I got a question about the Docker stack. Is that an add-on to Docker, or is that kind of
Docker Swarm is built into Docker. It's provided native. That's Docker Stack is Docker Swarm. So pretty much, I got a core quota limit. That's cool. Go back to 4. But anyways, all right.